All right, guys, welcome back. In this tutorial we are diving into another distribution called multinomial distribution, and this distribution is generalization of binomial distribution. You know, binomial distribution always deal with something that has to do with true or false, whether something is valid or not, like head or tail, or probably you're tossing some kind of die. But what if you have all this kind of true or false coin, like maybe 3 or 4 places that you want to analyze, or probably you have dice that you want to probably toss that is more than one dice. You know, this one binomial has to do with one thing, maybe a die that you're tossing and probably a coin that you're tossing, but this one has to do with varieties of coins, varieties of dice. You know, that means you're having more than one thing to actually consider in your head as true or false. And if you're doing this, you need binomial word distribution. And in order for us not to tell you much of stories, let's dive into the practical. As I said, I'm going to import numpy as np, but we might not do that. Let's just say from numpy from numpy import random, and we're going to say import math plot lib.py plot as p or t, and we'll say import c born as SNS. Okay, so we want to do that. Let's run the code. Let's see whether we are going to have some kind of errors. So okay, let's run it. You can see we're not having errors. So what we're going to do is that let's just say okay, SNS dot this plot. Okay, we now open it. Let's say random dot, what is the name of the multinomial? Just say multinomial. And when we have multinomial, we now have, there's one thing I didn't explain in there. It has 3 parameters, numbers of possibilities. So it brings up numbers of possible outcomes. So instead of me, I'll just say numbers of possible outcome. I say numbers of possible outcome is 6, right? Okay, fine. If you have numbers of possible outcome to be 6, you know, because if you're tossing down, the outcome is going to be either 6 spaces, and the p-var list of probabilities of the outcome. You know, probability might be 1, it might be 2, it might be 3, it might be 4. So let's take, for instance, we want to have probability that it might be 1 for all the dices. Okay, fine. We can just let me just copy this. I don't want to be typing it. Just copy all this like this. All right, I just copy it, and here I just say okay, p-var so equals, I will just say because I'm going to put it in form of like a list because it is more than one thing. Okay, so if you want to do that, you just say okay, let's do this and paste it then in there. All right, by the time you do that, you are good to go. So once you do this, you know, because you've already, you know, set the cborn to display it in form of graph, that's why you're having this plot, and we're good to go. Now we can load it. All right, and let's see what's going to happen. Okay, we're having some couple of errors. What's going on? Multinomial, not multinomial, multinomial, but multinomial. Something is wrong somewhere. Let's try to figure it out. Okay, what's exactly is going on? So multinomial takes at least 2 parameters. As what's going on, we added 2 parameters. Multinomial take at least 2 positional arguments, 1 given. All right, okay, fine. I think we added 6, n equals 6, and p vowels. Okay, sorry, this is 2, supposed to be 1 like that, I think. Okay, let's run it. Okay, something is wrong. Multinomial takes at least 2 possible arguments. What's going on? Let's figure it out. All right, I think we're still trying to figure out, but let's do it this way first. Let me just have this random dot multinomial ntx p vars 6 1 of 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 6, and let's say sns dot dist plot, and let's put it in the brackets. All right, and let's run it. Okay, fine, it works now. I think there's a mixed up somewhere which I can't really figure it. I just try to delete it and write it back. So this is it. You can see it gives us what exactly we're looking for. You can set to say plt because plt.show. Okay, so just get your using all these things. So there's nothing really, it's nothing, just get to using it. Okay, go. Okay, something's wrong somewhere. Internal error, unexpected indent. Okay, let's just reload it. Okay, fine, good, we're good to go now. So you can decide to remove the histogram if you like. I like to remove the histogram. I don't know why it makes me feel as if I'm doing something important. Don't mind me. All right, good. Histogram, I want to remove it. I remove it. You can see it's good now. So but if you want to put histogram, don't forget you can easily remove it like this. Okay, let's just get it done. Remove it like this and say dist. You want to remove the t and run it so that you're not going to be having those errors again. Good. All right, so that is that on that concerning multinomial. Okay, so in the next tutorial we'll take a look at some other distribution. I think this kind of distribution is a common distribution in statistics. If you've done statistics before, probably your first year in school, I think you understand what is known as exponential distribution, and that is exactly what we're going to take a look at in the next tutorial. All right, I think you're not getting used to using all this distribution. We intentionally want you to get used to it. That's why we want to at least touch so many distribution as possible and know how to actually apply this in the real life scenario. Okay, thank you, and I can't wait to have you in the next one. Bye.